That's right. You should say no, because if we look at this, all right, I want you to think of what's the domain and range of a normal sine function. Well, a normal sine function, right, the domain is negative infinity to the positive infinity, and the range has to be between -1 and 1. So, the range of the original function, which is sine of x, has to equal the domain of the inverse function. Okay? So that means the domain of our inverse function has to be between -1 and 1. -2 is outside of that realm. Alright, so this isn't possible. -2 is not in the realm of what we're looking for in the domain of the inverse function. So sine inverse of -2 does not exist. Okay, so even if you tried to test this one out on your calculator, right, you would, if you're in radians, right, you're going to hit second sine and then -2. It's going to tell you that you have an error there. Okay, so just remember, there's going to be a few homework problems, maybe a test question or two. They're going to verify that you understand if it's in the domain or not. All right, well, let's take a look at what that domain looks like now. So we're graphing the inverse function for sine. Okay, so sine inverse, or we call it arcsin. Arcsin is probably the more traditional way of calling it, but like I said, we might see it in calculus next semester as arcsin instead of sine inverse. You just need to understand they both mean the same thing. It's a way of using the inverse function to find a given angle when you're given the ratio. So if we look at sine inverse, all right, the domain of sine inverse is -1 to 1, and its range is -pi/2 to pi/2. We've already talked about this. You can also graph it in your calculator. So you can go y equals and then type in sine inverse or second sine of x. Make sure you close the parentheses on the x there. You can hit zoom 7, okay, and you're going to see that it's kind of a sine wave that's oscillating vertically now between -1 and 1 on the x-axis, all right, and -infinity to positive infinity on the y-axis, essentially. It will go on, but if we look at this restriction on this range here, this is really the chunk we're looking at, okay? So there are some restrictions on this inverse function. So if we want to take a look at it, right, it's increasing and it's continuous on its domain, right? It has x-intercepts of 0 and its y-intercept is 0, right? Essentially the origin here. Okay, and so for all x in the domain, sine inverse of -x is negative sine inverse of x. Okay, that's kind of like one of the identities we had last chapter as far as getting rid of the negative in the argument. Alright, so let's talk about our cosine or inverse cosine. Okay, same kind of a concept. Swap x and y and solve for y again. Okay, so same thing, only our domain changes. So for this case, it's going to be between 0 and pi. Alright, 0 and pi. Because you need to think about, if we look at the original trig function, what's going on at 0, what's going to pi? Well, cosine of 0 is 0, right? Or I'm sorry, cosine of 0 is 1, and cosine of pi is -1, right? So that was our restrictions on y with the cosine function. So that means that's going to be our restrictions on our domain, okay, for the arccosine or cosine inverse function. So that's really where all that comes about. Alright, so let's find the y in each equation here. So we're given y equals arccosine of 1. So you can type this in your calculator and you can hit, as long as you're in radian mode, you can hit second cosine of 1. But essentially what's asking you in your head, what angle can I take the cosine of to get a ratio of 1? Alright, or when does that happen? Well, we should know, alright, that y has to be between 0 and pi because of the restrictions on our domain for our inverse function. So we know that whenever cosine is 0, alright, cosine of 0 is 1. So the theta, or the angle we're looking at, is when cosine is 0, or 0 is the angle. Alright, so y equals 0, so cosine of 0 equals 1. Okay? Fairly straightforward, fairly simple on that one. Okay, let's take a look at this one. Alright, we want to find cosine inverse of negative square root of 2 over 2. You can type this in your calculator, right? As long as you're in radians mode, you're going to hit second cosine. Make sure the square root of 2 is all in its own parentheses, divided by, you can put the negative with the top or the bottom. Alright, 2, and you'll get your value. Okay, but for us, it's, if we wrote this right, this means cosine of y equals negative square root of 2 over 2. So what angle, gives us a ratio of square root of 2 over 2? We got to start thinking backwards. It's normally going to be whatever angle is tied to 1 over the square root of 2, right? Because square root of 2 over 2 is normally when we have to rationalize 1 over the square root of 2. So we got to think about what triangle involves a 1 and a square root of 2, right, with an adjacent side. So that's our 1, 1 square root of 2 triangle. So we should recognize that's going to be 45 degrees, or pi over 4. Okay, so cosine of y equals negative square root of 2 over 2. So we have to ask ourselves, alright, what angle is that? Okay, and we have cosine of 3 pi over 4 is equal to negative square root of 2 over 2. So we could do pi over 4, right? But then we have to make sure that we're in the right quadrant. Alright, and we have to end up between 0 and pi. So cosine of 3 pi over 4 is the angle in question. That's where we get a negative square root of 2 over 2, based on where we are in the quadrant wise. Alright, we said it's a 45 degree angle, but we need to know that 45 degree angle in this case is the reference angle, or pi over 4 is the reference angle for where we're located. So that's why we end up using 3 pi over 4 and not pi over 4 when we do this problem. Alright, taking a look at the domain and range of the cosine inverse function. Okay, the domain is -1 to 1, which is normally the range for regular cosine of the angle, but since it's the inverse, we swap the domain and range, and the range for cosine inverse here is from 0 to pi. So it's this snippet of the graph that we have here in front of us. Okay, so it's decreasing and it's continuous on its domain. It has x-intercepts of 1 and y-intercepts of pi over 2. The graph is not symmetric with respect to the origin, okay, or the y-axis. Alright, and then tangent inverse, alright, or arctangent, we can treat as sine over cosine. Okay, but we got to do the inverse of it, right? So the domain is -infinity to +infinity. Okay, that used to be the range of the tangent function. Okay, and then our range of our arctangent is -pi over 2 to pi. Okay, and that was normally what? Our restrictions on our domain, right? When we had the regular tangent function. So that's what we're kind of looking at as we're graphing the inverse tangent function here. Alright, it's increasing and continuous on its domain, has the x-intercept of 0, and it has a y-intercept of 0, so that tells us that it's symmetric to the origin, so it's an odd function. Okay, and we have